Hi, in this video we're going to explore how to select best antibody candidates and automate your lead selection picking process with Platforma automatically. Here I already have a pre-set up project where I have 4 samples coming from 3 rounds of enrichment of selection with phage display, with pre-processed data with MyXR clonotyping, and then a couple of very important things. To do antibody lead selection, we need to do the clustering analysis that we have done with clonotype clustering log. We need to have some scores generated by, for example, clonotype enrichment block, which calculates, which finds clusters or individual antibodies that were enriched across rounds of selection. For antibody discovery, it's very, very common. We need to have predicted sequence liabilities. That's done with antibody sequence liabilities block. And the last prerequisite before we start with the lead selection is the clonotype space. That's a universal tool allowing to explore the entire space of our antibodies. So now with this setup, we are ready to do antibody lead selection. And this is done with the block called Antibody TCR Lead Selection. So let's add this block to the project. And here we are. Let's select the data set. I'm going to select the data set where we redefined, where we changed the definition of the clonotype to the VGA region protein sequence. And now we see that immediately some parameters were set up automatically. For example, this filter by automatically picked up the information about liability risk. And this is done because upstream to lead selection, we have antibody sequence liabilities block, which exports this information about the predicted liability to downstream blocks. And the default filter is obviously we want to look only on the antibodies that are free from any liabilities. Next, maximum cluster enrichment. And that's another filtering criteria that is used automatically here because we have a clonotype enrichment block. And the threshold which is set up there is actually the threshold which you can see here under the stats tab. So the enrichment cutoff is the default that is recommended by clonotype enrichment block to use as a cutoff to filter on the clusters. And this is important. We did enrichment analysis on clusters. So here we are filtering clusters. And this is the default value. We can change it, no problem. Remember that maximum cluster enrichment, the score, is a log-to-fold change of the cluster abundance across rounds of enrichment. And that's it. We already have a filter table. And in this project, we have 888 antibodies that are satisfy this filters. But now our goal is to select some of them because we, for example, we may want to do a wet lab validation of those leads. So let's put the number here. Let's say 50. Pick top candidates. So once I hit 50 here, this will run the additional, well, we call it picking algorithm, which will pick 50 antibodies from those that are satisfy those filters. And the algorithm which does this picking will try to pick the most diverse candidates according to the ranks that we have here. First of all, it will try to pick candidates, antibodies from different clusters because, well, that's what we are aiming for. We're aiming to get like the most diverse set of antibodies. Next, how it will rank the antibodies or clusters of antibodies when it does this picking. It will rank them by this ranking criteria. And by default, we already have here maximum cluster enrichment added because we have the score, and obviously among all those antibodies coming from different clusters, we want to pick those that belong to the most enriched cluster. So for example, if we have 100 of clusters and we are picking 50 candidates, then we will pick 50 candidates from different clusters, obviously, and those clusters will be ranked by this criteria. We will start picking from the most, with the cluster with the highest enrichment. But then imagine we have just 10 clusters and we are picking, which satisfy this criteria, and we are picking 50 candidates. Then we will end up to the situation when we are picking candidates from the same cluster. And that's why we may add additional ranks. For example, let's say one of the very typical one of the typical ranking columns that we're going to use is distance to the centroid. And highest or lowest, meaning that we are picking the candidates either the most distant to the centroid of the cluster or the closest to the centroid. And then we may add other ranking criteria, like we can add the for example, the number of mutations, number of somatic mutations in the V region or the J gene region, or the candidates that are having highest number of somatic mutations, etc., 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 etc. So let's return to the defaults. Let's click the run button, and um, it is once it is finished, we have a list of 50 antibody candidates. Well, the number that we put here in the settings. How we are going to explore this list? Well, the first thing here, you see the other tabs that we have. One tab with the clonotype space, which will show the exactly same clonotype space, but with the candidates that we picked here in this block used to highlighted by default. And we can enrich our visualization with various things. We can to confirm that those candidates actually located in the regions of the clonotype space that we know good, etc., etc. We can also check the spectral type, like the distribution of the lengths of the CDR3, for example, among all of our leads, or the gene usage distribution to see whether we have some biases here. So if we select a lot of candidates, then obviously we'll have a more even distribution here, and that will be a signal that we are collecting nice candidates. One more thing we can do, we can select our candidates and compare them on the multiple sequence alignment, for example, which in this case is an instrument to show the diversity of our leads, and it really validates this fact. So we have a really diverse set of leads picked by the algorithm, and the same can be done here on the clone type space. We can navigate to a certain regions. We can navigate to the places around our picked leads. So here, for example, we have uh, we have the place where we are picking the leads. We can do lasso, for example, and see whether around this uh, part of the space we have some conservative motives, whether maybe we can change, we can decide toward the other lead here, etc., and do additional fine tuning of the list, which is already good enough of our antibody candidates. There are way more functionalities that you can play around with those rankings, with those filters, etc., and all them are very, very useful to build the list of antibodies that you trust. That's it for today. Thank you.